Hi everyone, good evening. In this lecture series, we are going to discuss about the three basic propagation mechanisms. So we are going to guess what are all the topic we are going to see in this lecture series. The first thing we are going to see what are all the three different propagation mechanisms. So before that, just we are going to recollect the waves what we have used here. We are using the radio waves. The term radio waves or nothing but the electromagnetic waves, and the frequency range is from 0.001 hertz to 10 power 16 hertz, and the wavelength is ranging from 3 into 10 power minus 8 meter to 3 into 10 power 11 meter. So the radio wave comprises of both the electric as well as magnetic field. So this is the classification of the radio waves based on the frequency. So already we have discussed about the radio waves. At the same time, so what are all the frequency we are using, that is extremely low frequency, very low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, extremely high frequency. So these are all the bands. So for the corresponding bands, we have to allocate the range and the wavelength range. For example, if I have taken the high frequency, so what is the frequency range that has been allocated for this high frequency is 3 to 30 megahertz, and the wavelength is from 10 to 100 meter. So as I mentioned in the previous slide, we are having very low frequency and all. So how much of the frequency ranges has been allocated? For example, if we are using the UHF or whatever it may be, radio astronomy, so the wavelength and the corresponding frequency ranges has been mentioned here. So next one we are going to see about the propagation mechanism. It is very important. Before that, before going to see the propagation mechanism, we have to know what do you mean by a line of sight. Apart from that, we are going to discuss about what do you mean by reflection, diffraction. Another one will be scattering. So line of sight transmission. So line of sight, it is nothing but a type of propagation where transmit and receive antennas are in view for each other. Suppose if there is any sort of an obstacle that does not exist between them. So here we are having the FM radio, microwave and satellite transmissions or the examples of the line of sight. So the reflection, what do you mean by the reflection? Suppose if there is an abrupt change in the direction of a wave in front of an interference between the similar media, at the same time, suppose if the wavefront returns into the medium which it was originated. Reflection is the result of digital TV signal shifting on obstruction with properties of the thickness and the length, and it will be larger than the wavelength of the radio wave. Diffraction. So what do you mean by diffraction? Means suppose when the diffraction occurs, means when the signal encounters the edge or the corner, at the same time the size is larger than the wavelength of the signal. Example, if we are going to cut an edge of the building roofs and the mountain tops, these acts as the secondary sources and there will be a re-radiating into the shadow region. It is due to the diffraction effect that radio frequency energy travels in the urban environment, and there will be no clear line of sight between those two antennas. The next one we are going to discuss about the scattering. So what do you mean by scattering? Means the scattering occurs when the signal encounters smaller objects of size smaller than the wavelength of the signal. So it results in a disordered or random change in the energy distribution. So it depends upon the smooth surface and the rough surface. In the smooth surface, we are having the specular reflection. At the same time, when it touches the rough surface, it will be scattered. Multipath propagation, we know that we are taking the multipaths arrive at the difference at the different times. The signal will be received at the point of the intersection. The next one we are going to see about the fading. Um, the first thing is that is small scale fading. It is concerned with the rapid fluctuation of the received signal strength over a short distance, and the large scale fading occurs when the obstacle comes in between the transmitter and the receiver. Thank you.